Good morning, good afternoon, whatever the case may be. I'm Tony Dubiel, Technical Solutions Architect working for Enterprise South area. And today I'd like to provide you with a Netdevops demo focused on ACI and CICD, continuous integration, continuous delivery. And for the premise of this demo, you do need to have some prerequisite knowledge in ACI, primarily around ACI constructs such as the fabric and tenant objects, as well as the object model that ACI uses for programmability. And we'll be taking a deeper dive into some of the tools that our customers typically use in their tool chain. So without further ado, I'm going to walk you through what some of those common tools are that we experience when we work with our customers' network teams and more recently, the DevOps teams. And we'll walk through those and unpack some of the detail there to kind of set up the framework and a backdrop for the demo. And after we have a decent level set, then we'll jump right into the demo. And again, even if you're just getting started with programmability, perhaps you know a little bit about Ansible, which would be good because we're going to use Ansible as our configuration management and deployment tool. You can still follow along, even if you're not as comfortable with some of the other terms and tools that you'll see in the CI/CD toolchain, and just kind of think of it as a way of perhaps looking into the future of how you would like to proceed in your journey in NetDevOps, and kind of the art of the possible of where you could take your network automation, through that progression through network as code, and then ultimately introducing CI/CD pipelines to include automation around your building and testing of your network infrastructures and the changes that you would make to those infrastructures. Now let's take a look at the taxonomy of a typical DevOps CI/CD toolchain with some example applications. If we first take a look at the SCM, the source control management, we can see that for the most part, typically our customers are using a repository in order to source control their code, and primarily those tools are using the Git protocol. So some examples being GitLab, GOGS is Go for Git. We have GitHub, either the public facing software as a service version of GitHub, or there is a GitHub Enterprise that you can deploy internally inside your private cloud, and other tools such as Bitbucket, and there's many more out there. JFrog being an example of an artifact. Um, Artifact tools are typically used for storing images of the completed code build in the context of an application development use case. However, in terms of networking, primarily the artifacts would be the completed configuration files. So whether it be a box by box configuration from either a router or a switch, or perhaps a controller-based solution such as ACI, where we take advantage of having an APIC in play as a controller that provides a single touch point, not only for programmability, but also a single touch point for understanding the configuration and state of the ACI infrastructure or fabric in this case, as well as a single touch point for configuration management and configuration rollback if needed. So those same configuration files can also be extracted or exported out of the APIC controller and then stored in common artifact tools such as JFrog or something along those lines, where we can use that as our ultimate off-box repository for our completed configuration. So the SCM, in terms of source control management from a network as code perspective, primarily is the code and checking in that code so that you can maintain a master copy, or what we sometimes call a golden image of the working template, um, if you will, from a networking perspective, where the template itself is no longer either a GUI template file or a command line template. The template is actually the code. So those text files, as a result of using some sort of coding tool, whether it be Python. In our demo, we're going to take a look at Ansible, but our coding tool, also known as configuration management tool, because in the network space, we're primarily adding configurations to a device or to a controller, or we're requesting operations data, from those devices. There's other examples, perhaps more advanced examples of orchestration tools. So, from a Cisco viewpoint, we have orchestration tools that primarily service a specific architecture where Cloud Center would focus on private and public cloud use cases, and NSO, the Network Service Orchestrator, is primarily focused on network architectures and bringing a capability of a notion of a multi-domain orchestrator to the network space. So what I mean by that, by multi-domain, is in the data center, we could have ACI as an example of a controller-based solution, software-defined networking solution. Um, but in the WAN, we have software-defined WAN, VIPTILA in the case of Cisco, and then in campus we have DNA Center with all of the wireless and wired devices as part of a software-defined access solution in the campus. And in colos, we have that notion of multi-cloud, where we can interconnect customers to multiple public cloud providers, and NSO serves a purpose there too as an orchestrator that has the ability of providing multi-domain, multi-site, and multi-tenant orchestration, across multiple domains in the network space. So that kind of covers the coding side of this, where if we create a code, that code could be a YAML file specifically for Ansible in this case of the demo. But if we were using Python, that code would represent a py file, a Python file. The code could certainly be HCL, which is HashiCorp configuration language, if it were a Terraform configuration file. And depending on the tool used, then the syntax of the code would vary for that particular domain-specific language. However, what they have in common is that code is a text file, and that text file would be committed into the source control management solution, GitHub as an example, or GitLabs. In the demo, we're going to use Gogs. It's an open source free tool that looks and feels and acts very much like a GitHub Enterprise. So we're going to use that for our purposes in this demo. But we would check our code in so that we have that golden copy in our master branch. We're also going to work from a development branch to demonstrate best practice in that regard. And then from a build and test perspective, there's many capabilities brought forth from a build and test automation tool such as Jenkins. GitLab actually serves a dual role where it provides a front end repository, but also has the ability to manage a pipeline in terms of build automation and test automation, where Jenkins is primarily focused on the build automation and test automation, and not so much a repository. However, it does support plugins that allow it to support all these other options that we have available to us as a end user. And from a test automation perspective, Jenkins, in particular for this demo, has the ability in the pipeline to call other tools either through plugins or through webhook integrations, where a webhook is basically a way that software can communicate to software through a REST API. So we'll take advantage of both of those in the demo. And then we can communicate with other tools. So in the non ACI network portfolio from Cisco, we have the ability of using PyATS, which is a Cisco contribution to open source, where this tool is a Python tool that allows us to automate testing using Python scripts, and the testing being low-level testing. So low-level testing in the context of network automation would include things like, testing state, and the state could be a routing table or an ARP table or a CAM or a TCAM table, things of that nature that we can do lower level testing. So that way, as we build our environment and test our configuration changes, not only do we want to identify syntax and semantic errors, we also want to identify any other errors that would contribute to issues with the state of the infrastructure, such as the routing tables and so on and so forth. So we want to identify those and then provide that feedback loop back, so that way we can resolve those issues in our lab environments before we promote those network configuration changes to production and commit them as our master copy into our source control management and repository. Another area that is interesting and where there's a lot of innovation recently within the Cisco and some of our software tools is the operations and analytics space. So from an operations perspective and analytics, what we can do is we can use these tools such as AppD or App Dynamics, Tetration, Cisco NAE, the Cisco Network Assurance Engine, which we will highlight in this particular demo, and its capability to identify issues with configuration change in an ACI fabric and to provide us with a root cause of the issue, an explanation of what the configuration impact is, or how it's impacting the state of the ACI fabric, and then provide us with a resolution that we can take action on to resolve the issue, and then run the configuration change again, and then ultimately, have that verification that we have a known good configuration change before we, promote that configuration change to our production ACI fabric. And there's many other tools from the security space as well, as other operations and analytics tools, logging tools, Singularity being an example of a logging tool that we can also incorporate into our tool chain and make those tools available as part of the pipeline that a tool such as Jenkins can manage from a plugin or a webhook perspective, to create stages within that pipeline that we can invoke these tools for their particular viewpoint and take advantage, of the data that these tools provide to make a decision on whether or not this particular build should pass and move forward from a test environment into production, as is the case in the use case that we will demonstrate here moving forward. Having said all that, let's go ahead and look at what's included in this demonstration. So from a pipeline perspective, and starting with the coding, we're going to use Ansible as our coding and configuration management slash deployment tool. And the code here are the Ansible playbooks. The playbooks are written in YAML, and the playbooks themselves represent the configuration templates that we will apply against the APIC controller. And we will effectively build an APIC from scratch. So this demo represents a bit of day 0 and day 1 configuration. Now, we never launch Ansible playbooks directly from our laptop in this particular demonstration. We're always taking the playbooks that are written in YAML, and anytime we create a new playbook, a YAML file, or edit an existing YAML file, we commit those changes into our repository. For the demo, we're using the Go-Git service, GOGS, to represent our GitHub repository, where GOGS looks and feels and acts very much like a GitHub Enterprise tool. Now, the GOGS has a webhook integration into Jenkins. So as part of our pipeline that we will demonstrate here in a minute, that pipeline would invoke an Ansible, which is running in a workspace as part of the Jenkins. So it's not the same Ansible, you know, the Ansible engine that's running in our laptop. Again, it's an Ansible engine that's running in a server where we have Jenkins deployed. So Jenkins would launch those playbooks, and as those playbooks run, if at any point Jenkins receives a failure from an Ansible playbook, then the pipeline would stop. Now, in addition to the syntax and the semantic checks that we would glean, from a failed playbook, effectively either a configuration error or something to do with an API call behind the scenes not working properly from the Ansible ACI module. We also wanted to perform some lower level checking of the state of the ACI fabric and any intent issues with the configuration that we are building in the ACI fabric. And that's where we're using the Cisco Network Assurance Engine to do a double check, but the double check is actually lower level checking of the configurations where CNAE effectively runs through some consistency checks and other checks, over 5,000 checks exactly, that would determine any issues, either configuration drift or impact with the ACI fabric state. So if we receive any issues, then in our Ansible playbook that is interacting using the API of the Cisco Network Assurance, which recently has GA'd the API support for the product, if we receive any counters in terms of a configuration change that show that there was actually, an adverse impact from the configuration change, then that pipeline again would stop. Similar to the checks that were made earlier in the pipeline, any failures would stop the pipeline. We would receive a notification back using WebEx Teams. So we have a WebEx Teams bot that is a part of a team space. We would receive a notification and a link saying, hey, we received a failure in the pipeline due to the Cisco Network Assurance Engine feedback. Here's a link to see what that failure was and ultimately learn what the recommended resolution is to fix that configuration issue. So once that configuration issue is fixed and we again launch the Jenkins job for making that change, then if everything is okay, then ultimately what would happen in the pipeline is that code would be merged from our dev branch that we're working from in the left-hand side of the demo over to our master branch, where we would ultimately promote that configuration change and use the master branch of the Git repository to push those changes to the production APIC. So we have effectively on the left, we have a dev APIC on 225, and on .226, we have our production APIC that we would only make a configuration change if and only if everything is tested and works okay in our dev environment. So without further ado, let's jump into the lab and take this all for a spin. So before we launch our job from Jenkins, our pipeline, I just want to show you that we only have a out of the box configuration in our APIC for our test environment, the .225. We just have the common tenant infrastructure and management, and as we launch our playbooks from the pipeline, you'll see that additional tenants, demo 1 and demo 2, will be built in this environment. We'll start here with Jenkins, our build and test automation server. And we can see that we have two jobs here, Pipeline and Pipeline 2. Pipeline was written to make changes to Cisco routers with iOS XE. Pipeline 2 is my ACI demonstration. We can see here that the last test failed for whatever reason, so hopefully we have better luck now as we run through this pipeline in our demo. So what I want to do is go into Pipeline, and as you can see, we're interacting with a GUI. But just note that there is also an API for Jenkins, so you can use your coding and configuration management tool of choice to actually manage and create pipelines in Jenkins. But for our demo, and due to my current skill set, we're going to use some of the GUI and some of the scripting, the Groovy scripting available to work with our pipelines. So let's go ahead and build a pipeline. So I'll hit build now, and then we'll get this job started, and then I'll show you, I'll unpack and we'll dissect some of the components under the hood here. So if I look at the console, I can actually see the pipeline that's being invoked. And we actually missed some of this, so we'll come back and take a look at this. But as I scroll down, we actually catch up to where we are in the pipeline build. Primarily what you are seeing on the screen here is the Ansible playbooks that are invoked from the server where Jenkins is running from. So these particular playbooks and these tasks are related to building configurations in ACI. So at this point, it looks like we are building tenant constructs. And before and up until this point, prior, we were building some of the fabric related configurations, more of the day zero configurations. And we'll look at that as we move forward. But let's just stay with this, and then I want to show you the pipeline itself so you can kind of understand what Jenkins is doing from a automation viewpoint. You can see that there's some pauses that I put in here in the playbooks, and that was just so that we don't oversubscribe the ACI simulator that's running in the test environment. And now we're at a testing stage. So this is going to pause for 5 minutes. And the reason why we are pausing is because the Cisco Network Assurance Engine is a big data application. It has Hadoop under the hood. So every time that it does the analysis of the ACI fabric, it's like a snapshot, or what they call an epic. And during that analysis, you can tune how often you would run through a snapshot or an epic of the ACI fabric. So in this particular demo, we have it set to every 5 minutes. So if we make a configuration change, then we have to wait for 5 minutes before we can actually see it identified and report it back to us in the Cisco Network Assurance Engine. So that's why I had the pause here. So while we're paused, let me scroll back up here to the beginning of the job, and let's take a look at our repository so that we can see our pipeline file, our Jenkins file. So here we are in our GOGS repository, and as you can notice right away, it looks much like a GitHub page. So here's the Jenkins ACI Ansible repository, and this is the code that we're working from. We have these files actually on my laptop as well, and as we make changes, we're going to commit those changes, into the repository. So in the playbook folder here, we have all of the playbooks that we're working with. I mentioned we're doing some day zero configurations, so like discovering the fabric, adding IP addresses, out-of-band IP addresses to the fabric. BGP configurations are day zero related in terms of route reflector configuration and things of that nature. And then we have the common tenant that we use for layer 3 out, as well as the actual tenant configurations. So those were the playbooks that we saw here. Here's some other integrations like VMM for VMware integration for the hypervisor, and then VLAN pools that we need to associate to our domains. So one thing that we do want to take a look at here while we have the chance is we want to go back a directory in our repository, and we want to look at our dev branch, because I mentioned we're working from our dev branch initially before we commit those changes to the master. So right now we were using this particular Jenkins file for our pipeline. So the syntax you see here is Groovy. So Groovy is the syntax that you use to create from a command line a working pipeline in Jenkins. So the first thing we're doing in Jenkins in our pipeline, the first stage here, is to clone those files down from the repository to our working directory, or our workspace rather, that we will invoke any other applications that we call from our pipeline. So in this case, we're going to call Ansible, and that Ansible would run from the server that Jenkins is running on in this workspace. So we need to pull down those files from our repository. So that's the first thing that we do. And then the second thing that we're doing is the build stage. So in the build stage, we are actually running those Ansible playbooks. Now, you'll notice right away we have this -I argument with a host-dev text file. This is our inventory file that points us to the dev, our sandbox environment, our dev APIC, which is an ACI simulator that's running on .225, and we're using this particular host file. This is the only difference here, is that I have a host file for the lab environment, the dev environment, and I have a host file for our production environment. Everything else is the exact same code. So we're practicing a best practice where we separate the code from the environment variables. So in this case, the environment variables includes the IP address and our password credentials and our inventory that points us to an APIC that is in our dev environment. So if we run through these playbooks, the first one being discover the fabric, add out-of-bound IP addresses, then a VLAN pool that we associate to a physical domain, and then we have VPC profile where we create our switch profiles and our interface profiles, interface selectors, and those API configurations that we need to communicate to the endpoints. We also have a VMM domain that's not really doing anything because it's a simulator. You can integrate with VMware, but you're not really connecting to the endpoints. And then ultimately, we have a need for external connectivity. So in the common tenant, I'm creating a layer 3 out and a contract that we can use so that when we build our tenants, in this case, we're building demo 1 and demo 2 tenant, then we use our tenant specific playbooks from here. Now, this playbook, and you can see our job failed. This is a notification to my WebEx team space. So we'll take a look at this in a second, and I'll tell you why this failed as well. I kind of did this on purpose as part of a use case that we're going to look at in this demonstration. So that's what this is. That was a result of the Cisco Network Assurance Engine. We did populate counters for our config change. So those counters were based off of a configuration that the CNAE did not like. From looking at those 5,000 configuration checks, something triggered a counter. So we'll take a look at why our pipeline failed. Now, if our pipeline had if it were successful, then what would have happened is we would have passed on or to the next subsequent stage. So the next stage is merge to master. So if everything was okay in our dev environment, then we would merge our code to the master, and that's what these git commands are all about. So on our workspace, and running from that particular environment, the Jenkins server would use its bash terminal to run these commands. So that's what these files are. They change directories into our workspace, and then we're running these git commands because we have a git repository that's running on the Jenkins server so that it can interact with the GOGS repository. So we're going to check out the master, and we are going to use the origin master, which is the GOG server, not the master that's running locally on the Jenkins server. And then we're going to merge our dev environment to that master, the remote master, and then we're going to push our changes. So those are git commands that are running from the Jenkins server. Once we do that, we have a notification that we have merged our dev branch to our master branch. If everything was successful, we'll receive that on our WebEx team space. And then ultimately, we would run the exact same playbooks, right? So reusing that exact same code with a host prod inventory file, which has the 22.226 host, which is our represents our production ACI. Now, as we move beyond that, we would receive a notification that everything was successful, and we would be able to move forward, and our production change was okay, and everybody is happy. So here was that WebEx team space notification from our WebEx bot. The bot is called Netdevops CICD bot. This is what we saw pop up on the screen as a notification. And what it says is that your job failed. Pipeline 2, that's the pipeline that we're working for the ACI as code demonstration. And it's saying that this was the job that we ran. So if we click on this, it takes us back to Jenkins, and then it takes us to where we had the pipeline 2 job. 61 is the actual number of that job. It says check Cisco Network Assurance Engine to resolve ACI configuration errors. So it gives us a link back to the real-time change analysis. That's the engine that's running in Cisco Network Assurance Engine that is monitoring any changes that are made, and if ultimately those configurations have an adverse impact on the intent of the configuration based off of those 5,000 checks that we talked about. So we can just click on that link, and then ultimately that should take us into the Cisco Network Assurance Engine. So here we are at the dashboard of the real-time change analysis, and we can see that we have two minor hits here. So that's what interests us, right? Because as we scroll down, we can see that we have the tenant configuration, and we had built demo 1 and demo 2 tenant, and each one of those new tenants that we iterated through our playbooks have an issue. So what we can do is drill down into the real-time analysis and we can learn more information. So this type of error is a forwarding policy, and it says that the event means that the EPG, one of the EPGs that we created in our new tenant, does not have a bridge domain associated to it. So we can click further into this and we can find additional information in terms of a resolution. So what the Cisco Network Assurance Engine is telling us is that we need to associate an EPG to the bridge domain. Now, normally that configuration from a GUI is hard to error because as you go through the drop-down menu, you have to select a bridge domain. Otherwise, you will not see a next button as part of that workflow that is curated for you with guardrails, using the web GUI. Now, in automation, the benefit is that we can go much quicker because we're no longer bound by a GUI, and we can use these coding tools that have a better mechanism for communicating directly to the machine. However, from an API perspective, if you miss a configuration, there really isn't anything, a wrapper around that, like as in the case of the GUI, to stop us from making that configuration with an omission. So that's what happened to us here. So this is the Web 1 EPG, and we were missing the bridge domain. So if we go into the APIC, and if we click on either Demo 1 or Demo 2, I can show you what happened. It's a big oops here, right? And again, automation lets us go quicker, but automation also allows us to make more mistakes unless we have automation in check with proper testing. So that's what we implemented here with the Cisco Network Assurance Engine to look over our Ansible shoulder, if you will, and it was able to identify a missing configuration. So we go into the web EPG. I'll actually click on the web EPG itself and go to policy. Moreover, we need to click on the icon, so we drill down into the configuration for the web EPG in demo 1. And we can see that we are not selecting a bridge domain. See? So it's a drop-down menu that normally we would have configured from here. So in order to resolve the issue, we're going to go ahead and not fix it from here. We're going to fix it from our code. So what we need to do is actually go to the code. Okay, here's our code. Before I make the proper fix to our Ansible playbook for the tenants, I wanted to show you how the Cisco Network Assurance Engine was able to work from the Ansible playbook that we invoked from the pipeline. So that's a part of my playbooks. So we'll just go ahead and take a look at it from here. Playbooks, CNAE, YAML. So basically, in order to interact with the Cisco Network Assurance Engine with Ansible, at this point in time, we don't have the published module for Ansible. So I actually have to use API commands. So I'm using the API module within Ansible to interact. So there is a handshake for a token that we have to look at. I'm not going to go into details in that right now. What's important is I had some logic in this playbook that I use for a condition. So basically what I'm saying is if we have a count greater than 5, and the reason why the number is 5 is because in the out-of-the-box configuration of ACI, there is an information counter that starts at 3. There's a couple of things that I'm unable to clean up because I don't have a valid license, and some of the other dependencies that trigger some of these events in the APIC, such as only having a single APIC versus multiple APICs. So because I'm unable to resolve those issues, I do have some counters out of the box. So I'm starting with 3, and then if I see anything or I'm sorry, I'm starting with 5 rather. If I see anything additionally added to 5 from a counter in my real-time change analysis adding to my total counters, then that triggers an event for me. So what's happening is I'm parsing out JSON values that we're requesting from the Cisco Network Assurance Engine, effectively interacting with the API versus using the GUI, and I'm able to pull in that information from the specific counters. Now, the condition says that when I have an event or a counter that exceeds 5, then what's going to happen is I'm going to invoke this playbook, which actually launches an invalid URL for a REST API. So ultimately, that will fail the playbook. And I mentioned earlier that if a playbook fails in the pipeline in that stage, then it causes the pipeline to fail. So that's how it was able to trigger the failure notification that told us that we failed because of the Cisco Network Assurance Engine and gave us a link to the actual page of the real-time change analysis so we could take a look at what that failure was. And then ultimately, we were able to understand what the resolution and the root cause was from the text. Now, as I progress in my skill set of using this brand new GA API, what I'd like to do is be able to pull in the JSON of the actual resolution and see if I can go a bit further with a cross launch or something along those lines. But for now, I can learn there was an issue and act on it, but I still needed to look at the GUI for further details. Okay, so now let's look at the tenant playbook. All right, so there's a lot going on in here because we do have ACI modules available. So that's what we're using in this particular YAML file, and there's a lot of configuration that's tenant specific. So you see lots and lots of configuration here. So just a real quick overview of what's going on. Again, we're not able to spend too much time on Ansible, but I wanted to give you a little bit rundown of what's configured here, at least from the tenant perspective. So this is a playbook. And what we're doing is we're looking at a host file called APIC, or I'm sorry, a group called APIC that is included in our host file. Now I have two host files. So in my Ansible playbook running from the pipeline, initially I'm pointing to host-dev, which has the .225 address. If we resolve our issue, we should be able to progress at that point in the pipeline where we would move forward and use the host-prod text file, which would point us to the APIC that's at .226, which represents our production APIC. And we're running these exact same playbooks. It's really just the host file is the variable here that's different. Okay, so the next thing that we're doing is, we actually have the modules that we're working from, and they require information. So we have variables that we've put together here. So we're including variables. The first set of variables is just the password credentials. It's best practice to, again, decouple credentials of those environment variables from the code. So if this were a true environment, we would encrypt our password credentials using the vault capability of Ansible. But since this is only a lab, I didn't add that extra step. Now, these variables, we're including variables where we're actually importing in a CSV file, and we are running a Python script that parses through the CSV file and converts that information into a JSON dictionary that we can use to iterate through for variables. So that's why we have this here, which is pretty interesting. And again, we're not zooming into the Ansible side of things, but I typically use CSV files for my variables, so that way I can repurpose them in Postman, Ansible, or Python, and I can use the exact same CSV files. Now, here we transition into an actual module. So this is the ACI tenant module, and these key values are really just the parameters that we're configuring from within this Ansible module. So an Ansible module behind the scenes is Python and API calls to the APIC, but on the front end, this is a YAML file, and it has a very simple to understand human readable format where we are effectively using indentation, and these hashes or these dashes for listing out multiple items or multiple tasks in a play that we've put together within a playbook. So as we scroll down, we've created a bridge domain, right? We can see that. That was fine, but we didn't associate the bridge domain. So, and that was the web EPG. So we move our way down. We created the web EPG, and we can see, oops, look at that. There's a comment. So if you put a pound or a hash, whatever you want to call it, that is a comment line in a playbook. So we would not act on that line. So that's why we did not associate the bridge domain to the EPG. So that was an oversight, on my point or my part rather, that we missed. So if I do an I because we're in the VI editor, I can remove that comment and then I can save it, right? And then what I want to do is I want to update my local repository, which will invoke the Jenkins file. The Jenkins file is where we configure the pipeline. That was that Groovy code that we looked at earlier. So anytime that I make a change and commit it, in this case to my dev branch locally, it's going to push it to GOGS, our GitHub, right? And when it pushes it into the remote repository, the Jenkins file will determine that because there was a change made, then it will run the pipeline to job again. And then this time it has the proper code, so it should pass through, and we should be able to invoke the pipeline from start to finish and see a notification at the end that everything was okay. So let's go ahead and go through that part of it by adding the file to our local repository. Oops, I have to put the actual folder structure in there. All right, so we've added it, but now we have to commit it. This comment is really for our purposes. It is required, but it's something that makes sense to us. And then we got to push it. It does require credentials. And these are credentials to our GitHub repository. So, okay, so we made our change. You can ignore these error messages are not really relevant to us. Okay, so after making our changes to the Ansible playbooks, we are on this new job 65. And if we go into the console output, we can see where we are. Scroll down, we got playbooks going off. We're actually in the tenant portion, almost completed there, and then we've got to wait that 5 minutes so that the Cisco Network Assurance Engine through the Hadoop backend can go through that analysis of the 5,000 checks and give us an update on where we are. And we'll use the API from the pipeline in order to glean on whether or not we can move forward or not. So we'll pause here and we'll come back after conclusion and we can take a look at if our pipeline was successful or not on this job 65 here. Okay, here we go. Moving forward. All right, we saw our notification come through. We'll take a look at that as we run through this afterwards. So we're in .226. That is our production ACI APIC. So as you can see, it's running through those exact same Ansible playbooks. The only thing that changed was the host file. And that was a part of our pipeline configuration, was to, again, to test first in dev environment and then point to the host file to production only after the testing passed. So after we fixed our bridge domain issue, we were okay. So here we go. We're configuring the tenant configurations. And then ultimately, if there's no issues there, then we should see a completion notification as well. Make it a little bit bigger. We're almost there. Okay, there's our success right? So we see that from not only the pipeline, but from a notification that was sent to our WebEx team space bot, right? So here we go. So we can look through here and see that our dev build was successful, and then we were able to merge our dev code to master. So we merged that in our repository, and then ultimately we were able to build our prod environment, our production environment. So that was successful. So this is the a reference back to the job 65 that we were just looking at from Jenkins. And then something else that we probably should look at is the APIC, the production APIC. Take a quick look there. And then I can go to the tenants and get rid of all these. These are those notifications and things that show up on Cisco Network Assurance Engine because of licensing and not having enough Apex and things like that. So we'll go into Devo 1, and we'll go ahead and take a look at our configuration just to show you that this time, we apply that configuration to our production environment. And we go to the web EPG, click there, click on policy, click on the icon. And you see our bridge domain here is demo bridge domain 1. Well, I wanted to thank you for watching this demonstration. Some of the key takeaways are definitely, think about code, whether it be Ansible or something else, Python, Terraform, even Postman. It really doesn't matter. The idea there is that, you're creating configuration templates as code that you can share. By sharing, I mean you're committing that particular template file into a repository, so that way you always have like the golden config that everybody can work from. And if a change is made, that change is always tested and validated. So that's where we incorporate additional components, such as Jenkins, where we can, automate the building and the testing of that configuration change. So with that being said, that's what we did. We had a failure. We were able to identify the failure by incorporating the Cisco Network Assurance Engine, and it was able to tell us that we had, hit a counter that said that, after making a change, there was an undesired, effect from that change because we were actually missing a required configuration that a tenant would need in order to have access to network resources. Without a bridge domain, an EPG is kind of dead in the water. So we were able to do that. And so we automated building our configurations, testing our configurations, and moving configurations into production with a high level of confidence that our change was successful and that we're able to move forward with the next one. So thank you again, and I look forward to seeing you on future demos. Take care.